produces a wide range of engineered thermoplastic and composite components in small batches. These parts are often of complex shape and typically have flash lines that are mechanically tough. Therefore, the parts were deburred manually. However, this process was very dangerous and time-consuming, and removing the flash lines consistently is a very difficult procedure. Greene Tweed therefore opted for a robot-based automation solution. The aim was to develop a robotic cell that could be flexibly adapted to a multitude of variants and different surface finishing tasks. The programming of the deburring application was realized with the ArtiMinds Robot Programming Suite.
It makes it easy to program lots of different geometries. So for us as a company, we have literally hundreds of thousands of unique products that we have. So for us to be able to be successful as an automation team, reducing setups and having cells and systems that can be easily converted from one product to the next is really critical. The first time we looked at a three-dimensional part and said, oh God, how are we going to create these profiles? The thought of programming them with waypoints in a robot became completely overwhelming. So we looked there, we found ArtiMinds and said, this looks like a great solution.
Instead of the time-consuming teaching of individual waypoints directly with the robot, the software allows to generate robot trajectories automatically based on the CAD models of the components, which makes the programming much faster and more precise.
The speed of deployment, I can't see it being faster any other way. I wouldn't even consider touching a project like a deflashing project like this without ArtiMinds.
Initially, the 3D model of the workpiece has to be imported. Then the edges that are to be processed can easily be selected and extracted. In the second step, the correct TCP orientation of the robot to the workpiece must be set. For this purpose, the software offers predefined orientation modes that can be checked in advance in the simulation. Afterwards, the created trajectories are translated into a template. This template contains all the points the robot is going to move over. ArtiMinds RPS offers numerous auxiliary functions that optimally assist the parametrization of material removal applications. To preserve the tool and achieve a slower, more controlled increase of force, trajectories can be modified or extended, for instance.
We can bring the geometry in, we create the paths, we can simulate. So I love the simulation in that we can test up and simulate virtually and really refine the process. And that's all relatively easy to do in ArtiMinds.
The filing motion performed by ATI's CRT is ideal for the narrow inner edges of the components. ArtiMinds RPS facilitates a reliable processing despite burr inconsistencies and geometrically complex components.
It's a really nice balance between having something that you can get on, learn to use, deploy something and add value really quickly, but then as you want to grow and develop and optimize, ArtiMinds is right there with you, and the technology will allow you to keep doing that.
Besides programming movements in offline mode, ArtiMinds RPS also allows the communication between peripheral devices and the integration of logical conditions to be set up without much effort. In most cases, the PLC takes over the complete program logic, which the robot then executes straightforwardly. Hence, there are digital I/O templates in ArtiMinds RPS that can be used to read diverse inputs or write different outputs. A number of a certain task the robot has to execute can represent an input, for example. Based on this information, the PLC is able to precisely control the time sequence of the tasks to be executed. In addition, different communication patterns, such as handshakes, can be performed, or peripheral devices can be controlled. In this particular project, cases were defined to adjust the air pressure of the deburring tool, meeting the requirements of a certain task, or to realize a tool change. The new robot deburring cell more than halved the processing time for Greene Tweed's parts. Thanks to ArtiMinds RPS, the engineering team was able to develop their application independently and significantly reduce their timeline to deploy this fully automated deburring cell. Furthermore, the team remains flexible in the future, even if the cell needs to be adapted to new requirements.
We know that it's extremely configurable, extremely customizable. And it's nice to have a software that you can grow into. Some of the other alternatives that we looked at are very, very simplistic and really don't give you much in the way of controls over a lot of the aspects. Whereas I feel with ArtiMinds, you can go to such an incredibly detailed and finite level of control and really optimize your process. So basically we engaged with the team, and it was a very, very two-way street partnership. I feel like we had a direct line to the guys that knew the programming. We know that when we need something, they're going to be there for us. And that's really important for us to find partners to work with.